So continuing on from our last video, we're going to study two different types of functions. So recall that in Algebra 1, if you had a linear function, which is just a straight line, the slope or the rate of change of the linear function was constant, okay? And we learned in the last video, and you know how to calculate slope. It's basically rise over run, y2 minus y1 over x2 minus x1. However, in calculus, we're going to encounter not just straight lines, but lots of curves, okay? And what we need to learn how to do is calculate the slope. What's interesting about this parabola that I've drawn, just as a simple example, is that technically the slope changes at each different x value. There are actually infinitely many slopes throughout this function as we move from left to right. So just as an example, let's say I was at this particular point here on the parabola, okay? And I wanted to sort of approximate or think about what the slope might be, right? What I could do is I could draw a really small tangent line, right, next to there and say, hey, the slope looks really negative, right? If you were to calculate the slope of that little segment there, that would be a negative slope, okay? And the tangent line, you may remember from geometry, is going to intersect that parabola in exactly 1 point. But then as I keep traveling down the curve, right, let's say I go over here and I want to calculate the slope or the rate of change, and I draw just a quick little tangent line to kind of approximate, a line to calculate slope. I notice, it's still negative, but it's a little less steep, right? So it's already changed. Now, down here at the vertex, right, the slope or the rate of change is actually 0. Remember, horizontal lines have 0 slopes. So as I move from left to right along the x-axis, the slope or the rate of change at each of these points is constantly changing. Furthermore, as I go this way, right, my slope is becoming positive, and up here it's becoming more positive. So there are infinitely many slopes on a curve. They're different depending on the x value. And that's going to be an important point, because in the next video, what we're going to do is ask ourselves, okay, how am I going to calculate the slope right at that exact point? Remember, our formula for slope tells us we need 2 points, right? So, I used to teach Algebra 1. I've never calculated slope without using 2 points, right? y2 minus y1 over x2 minus x1. So we're going to learn a really creative way to calculate the slope right here at this point. Even if we don't have 2 points, we're going to have to get a little creative. So stay tuned for the next video for that explanation.